Okay, friends, we're on episode 4 of Unit 10. This episode is titled Hyperbolas. I'm going to be straight honest with all of you. I have been fighting this lesson for an hour, and I still hate it, but sometimes you just have to walk through the trenches and just get it done with. So that is what we are going to do. So please bear with me as we journey through this fun topic together. Okay, here's what we got. A hyperbola. Here's what you need to know. This is if we took a plane and we cut a cone just like that, just straight, the two inverted cones, we cut them straight down the middle. And that shape we get is a hyperbola. And so I know every other shape I've given you some fancy definition. I'm not doing that with the hyperbolas. I do not feel the need. Here's what you need to know. Hyperbola. Basically, two parabolas facing away from each other. And that's the only definition I'm going to need you to know. Okay, so here's the reason that I'm bothered by this lesson is because there's a lot of information. Because, I could have like this, a vertical hyperbola, where the parabolas are facing up and down, or there's the horizontal and their equations are set up in different ways. And a lot of it is the same, but some stuff is different. And so I can't fit all the information for both of those on one slide. So I'm going to have to split them up. So I'm going to start with the horizontal hyperbola. Here's what this looks like. We call it a horizontal hyperbola because that's which way the parabolas will be facing. So basically you got a parabola over here, and you have one equidistant from the center over here. Now, here's the equation of this. X minus h squared over a squared minus y minus k squared over b squared equals 1. Hey, does that look real familiar to you? Oh, yeah, I sure hope so, because that's the equation of an ellipse. Here's your difference. Well, bam! That's the difference. Hyperbolas, we are subtracting. Ellipses, we were adding. So here's what we got going on. The center is HK still. That's nice. It's nice when some things stay consistent. All right, your A value is the distance from the center to a vertex. So let's say, in a fun twist of events, the B value you don't actually see on this graph. So why do we care about it? I'll tell you why. Because we're going to focus on the C value, which I'm just going to highlight on that side. C is the distance from the center to a focus. Remember focus of a parabola? That still exists. And here's, you remember how with ellipses it was like, oh, c squared equals a squared minus b squared. Suckers, this time c squared equals a squared plus b squared. And that's going to be our focus equation, and that's why we care about the value of b squared. Okay, a few other things we got going on. I don't remember if we've dealt with asymptotes. I think we did a little bit with exponential equations. Here's what you need to know about an asymptote. Okay, where's the best spot to write this? I'm just going to write it over here. Okay, asymptote. Make that your Wi-Fi password. It'll be super protected, promise. Okay, basically an asymptote, in this case, these are going to be lines that guide the end behavior of the graph. Of the parabolas. So here's what this looks like. They go through the center, and they're just guiding the parabolas where to go. And it's just, yeah, it's shaping those graphs as you go out. Okay, another way to think of asymptotes that I like to think of sometimes, an asymptote is like the friend zone, you know, it's a line you get really close to, but you never touch. It's like the friend zone, okay? So here's what you got as the equation of your asymptote. Notice you have two lines. They have the same slope, except they're opposites of each other. So that means one is going to be positive, one is going to be negative. So I'm just going to represent that with a plus or minus. And it's actually going to be the value b over a. If it was centered at the origin, it would just, that would be it, b over a. But to account for starting at the center, we're going to have an x minus h plus k. All that part does, it just moves your asymptotes based on where your center is. Okay. The other things we got to talk about. Let's go. Let's actually do this like scrub blue. All right, a transverse axis. Notice that if we're talking axis of symmetry, this hyperbola has two axes of symmetry, because I could cut it in half going this way, or I could cut it in half going this way. So I have two axes of symmetry. And so the transverse axis, this is the axis of symmetry, abbreviate with AOS. That has the vertices and the foci. So here's my hint for you. If this is a horizontal hyperbola, then it has a horizontal transverse axis. And that's just going to be at x equals, pranked ya. If it's a horizontal line, it's definitely a y equals. So this is going to be a y equals k. Let's do some pink next. Your conjugate axis is just the other axis of symmetry. So that would just be down the middle there. That's a vertical line, so that's going to be at x equals h, where the center is. Okay, that is a lot of information. You have the benefit that you have written this down, and you can refer to this as I do the next slide. I do not have that luxury, so we're just going to hope that it also looks pretty, because I'm just going to jump right in and talk about the vertical hyperbola. Dun, 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 dun. That's the sound a hyperbola makes, in case you're wondering. Okay. Here we go, a vertical hyperbola. Here's your equation. Y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, I want you to look at your equation for the horizontal hyperbola and just think to yourself, okay, what is the difference between these equations? I am hoping in your pondering time that you have discovered the only difference is that in the vertical hyperbola, y comes first. In the horizontal hyperbola, x comes first. So here's what we got going on. A lot of this is going to be the same. So the center is still going to be at HK. You have A, which is the distance from the center to vertex. Actually, I don't feel the need to write that down again. I already wrote it down once. You wrote it down once. Why write it down again? Okay, so you have A, it's still the distance from the center to a vertex. You have your C, which is still the distance from the center to the focus. And your equation for that is still C squared equals A squared plus B squared. Your difference here, this time with the asymptotes, this time it's going to be plus or minus A over B instead of the other way around. And then it still counts for the center there. And this time, the transverse axis, that's the one, remember, with the foci and the vertices. So this time it's a vertical line, so that's x equals h. And you have the conjugate axis at y equals k, because that's a horizontal line. All right, so there are just a few tips or like important facts I want to point out, which is why I'm going to write them in red. So here's what you need to know. The direction of the hyperbola is determined by the variable that comes first. So like we talk about, if it's vertical, y comes first. If it's a horizontal, x comes first. As far as like, because I think the confusing part, because notice that A and B don't change places. And so the confusing part gets to the asymptotes and like keeping that straight. And so legitimately, here's what I do every time. It's the variable in the denominator under x is the variable in the denominator of the asymptote. So that way I don't have to remember like the A and B. I'm just going, okay, looking at x, that's the one, the denominator. So for example here, oh, I see that it's B underneath x. Well, hey, look, it was B in the denominator. If I look at my other equation, the horizontal one, oh, it's A in the denominator under x. It's A in the denominator of the asymptote. So this assignment, all I'm asking you to do is identify each of these things. Identify the center, identify the vertices, the foci, the transverse axis, the conjugate axis. I'm not going to make you write equations for it. And I'll be honest, that is largely in part due to the fact that MathSpace does not have those questions. So we kind of lucked out in that this assignment got a lot simpler because MathSpace just wouldn't let me do what I wanted to. And, I'm not even mad about it. Okay, so example. I'm just going to call it find all features. Of the hyperbola. All right. And here is our equation. We're going to do y squared over 25 minus x squared over 9 equals 1. Okay, our first thing that's going to, well, first let's identify the center. going to write it over here because I feel like it. All right, notice H and K are not present, which means our center is at 0, 0. Okay, next, we want the coordinates of the vertices. Well, we look for the distance to a vertex based on that first denominator. So if a squared equals 25, that tells me that a equals 5. And now I also have to know, well, which way is this parabola opening? I see that this is a y squared, which tells me that my shape here is going to be vertical. So that means my vertices from the center move up and down from the center, which means that the y-coordinate is going to change from the center. So I got 0, -5, and 0, 5. Okay. Up next, we're going to want the foci. I remember that c squared equals a squared plus b squared. So c squared equals 25 plus 9, which that gives me 34. And now I'm going to square root both sides, and I get c equals square root of 34. If I want to be technical, I guess I could do plus or minus, but I didn't do that the other time, so, there's that. Okay, once again, the foci are going to be inside of these, and so that changed with the y-coordinate as well. So that's where I'm getting the plus or minus root 34 from the center. So that x-coordinate does not change, and I get negative root 34, and then I get positive root 34. Okay. So now we want the transverse axis. Well, the transverse axis is the one where all of those fun points lie on. So that's a horizontal, it's a vertical line, gotcha. The vertical line is an x equals, and it's just the coordinate of the center, so it's 0. And that means our conjugate axis is going to be the other one going this way. That's a horizontal line, and that's at y equals 0. Okay, that's all, I believe, for each part. Oh, I missed the asymptotes. That's what we're missing. Okay, asymptotes. Y equals plus or minus. Okay, well, we know that a equals 5. This 9 is b squared, so I know that b squared equals 9. Well, that tells me that b equals 3. I'm going to take the denominator that's underneath x. Oh, so b is underneath x at this point, so it's going to be a 3 in the bottom and then the 5 on top. And remember, it's like the x minus h plus k afterwards. Well, h and k are just 0, so that would be like an x minus 0 plus 0. That's the same as just x. So I get the asymptotes as y equals plus or minus 5/3 x. When you type it in a math space, it's going to want them both separated by lines. So it's going to just want like 5/3 x and then negative 5/3 x. Okay, and that's what you are asked to do for each of those questions. We're going to do another example where this time, like, the center has been shifted. Sorry, you saw me practicing. All right, so let's do x minus 4 quantity squared over 16 minus y plus 1 quantity squared over 36 equals 1. Okay, let's start with the center. Remember, it's opposite h, opposite k. H always goes with x, so it's going to be 4, -1. All right. Here's a squared. A squared equals 16, so I know that a equals 4. We have to know which way is the parabola opening up. Well, if it's x squared listed first, then I know it's going to be a horizontal ellipse. Wow, does it show that it's 10:52 at night? Because I just called this hyperbola everything that was not a hyperbola. I called it a parabola and I called it an ellipse. Point being, this is a horizontal hyperbola. Okay, so that tells me that from the center, this a value is going left and right, which means that the x-coordinate is going to change by that 4 in each direction. So my vertices, well, 4 minus 4 is 0, and the y-coordinate doesn't change. 4 plus 4 is 8, and the y-coordinate doesn't change. Okay, let's go for the foci. We know that c squared equals a squared plus b squared. So that gets us a 52. And then we take the square root. So c equals the square root of 52, which if I was to try and break that down, I get 2 and 26, and then 2 and 13. So I got c equals 2 square root of 13. Okay, so that plus or minus 2 root 13 is changing in the x direction because it's also going left and right because those are inside of your two parabolas. So first I'm going to do 4 minus 2 square root 13, and that y-coordinate doesn't change. And now I'm going to do 4 plus 2 square root 13, and that y-coordinate doesn't change. Let's do the transverse axis and conjugate axis because those were a little bit easier. Transverse axis, that's the one where all of this lies on. So I see that is a horizontal line. Horizontal is y equals. Well, what is the k-coordinate? Oh, that's just -1. So it's coming from right there. Y equals -1. And that makes my conjugate axis well, that's going to be an x equals, and it's just going to be whatever the h is. So that's going to be x equals 4. Okay, last thing we need to find would be the asymptotes. So I know y equals plus or minus. Well, here's what I see. This time it is a that is underneath x. And so I know 4 is going to be in the denominator. And here with this one, if I know that b squared equals 36, that means that b equals 6, so it'd be a 6 on top. And now we account for the center by going x opposite of h plus k. Well, that 6 over 4 reduces, so I get y equals plus or minus 3 halves x minus 4 minus 1. And those are the two equations of your asymptotes. Okay. The only other thing that you're going to see on this assignment that we haven't specifically talked about in this lesson is if you get something like 4x plus 1 squared minus 25y minus 7 squared equals 100. It's going to say, hey, what's the hyperbola? I hope this looks familiar from ellipses. Guess what you got to do? Because notice everything always equaled 1. So we're just going to divide by that right side. And then you get the x plus 1 squared over 25 minus y minus 7 squared over 4 equals 1. And lo and behold, you have a hyperbola. Okay, that honestly wasn't too bad, at least on my end. So, happy trails, everyone.